So just a real quick wee video here, boys. You may recall I was actually discussing the little frequency generator that I bought, I don't know, a month ago back or whatever it was. Good wee rig, dirt cheap, right? You can vary the frequency and the duty cycle, or pulse width if you prefer. However, it has some limitations. Here in the spec sheet, you can see that it says output amplitude. The pulse width amplitude is equal to the input voltage value. Well, okay, but I can see some shortcomings in that. If you want to use it in an automotive application, typically most pulse trains or sensors generate 5 volt pulses. There's exceptions, of course, right? I think there's some 8 volt and there's some 12 volt pulse trains out there as well, I think. But anyway, most of them, I think it's fair to say, are on the 5 volt level of things when it comes to the amplitude of a pulse train. So I have a static input voltage of 12.6 volts there, as you can see, boys. So another thing I didn't like about it is that there was no switch to turn it on and off, so it was on all the time. This is just a wee $2 dollar store box that I bought to just mock up this wee test rig, just a prototype, if you will. But here on the scope, you can see I have the 2 channels actually set up. Channel 1 is actually the upper channel here, the yellow. You can see it's just reading the 12.6 volts. 5 volts per division, 12.6 volt static voltage on channel 1. Channel 2 is actually the output, the pulse train, if you will, 50% duty cycle at 1 kilohertz, 1000 hertz, right? So let me just alter the frequency here. There we go. There's 673 hertz for no particular reason. Okay, so there's back on our scope. So as I said, what I didn't like about it was you're kind of tethered to the input voltage with respect to the output voltage, but you'll notice on the scope there that that's not 12 volts. Channel 2, also 5 volts per division. That's reading 5 volts. That's where the little potentiometer comes in. 2K potentiometer. All it did is set it up basically as a voltage divider. So I'm just tapping off the output signal from the little signal generator, and I can actually vary it, as you can see, in amplitude down to nothing, right? And I can bring it up to, that's my center point on my potentiometer for 5 volts, kind of standard. And sorry about the glare there, boys. No great deal I can do about that, I don't think. Let's see if I can get the angle a wee bit better. That's maybe a bit better. And there's the maximum that I can actually achieve. So it's about 8.5, 9 volts ish. Perhaps changing the value of the little potentiometer here would actually allow you to skew it a wee bit higher, maybe, if you desired. Or this is just not arbitrary, but kind of a starting point. Once you load the circuit up, maybe the voltage levels that you'll be able to generate will obviously differ, but this is just a starting point, boys. It's no regulated, of course. It's just a potentiometer. So that's it. I wanted to be able to vary the amplitude in particular, so it could get 5 volt output. You might recall I used this little setup to drive the coil on plug assembly there, boys, when I was demonstrating that. This is no ideal. I'm not happy with this. I've got a tower of stacked up banana jacks here to make this all happen, but I suppose I could refine that a wee bit, and when I actually do put it in a box of some sort. The only little metal box I had was kind of well, I didn't want to open up myself out for abuse for you or something like that. Yeah, so that's it. That's just a quick wee look at the little prototype, boys, giving you the ability to vary the amplitude of the output pulse train. This is the little prototype model, the DS1000. That's it, boys. Cheers.